last week you talked about scalar variables, array variables. We even touched on data types at a point, so there's a lot that we talked about last week. So we want to continue from where we left off, and literally we want to finish with the theory, the basic theory when it comes to programming. And then we are done. So let's recap from some of the things we did last week. I just want to make sure we are all on the same page. So now we say a scalar variable. What's our understanding of it? Okay. So it stores a single value. All right. Now the x is the variable. Okay. Storing the value of 50. The equal sign is the assignment operator. Okay. So if you don't understand this, you need to ask a question, because it's very fundamental to programming that we know variables. In fact, variables are implemented in C programming. It's a little bit more sophisticated than this. So you have to store the variable, you store the value to a particular address in memory. And that address can't be just a generic, cannot have a generic name like X, So there's a whole hexadecimal arrangement of numbers. That's the storage. And the advantage of that is that C programming therefore can be used for embedded programming. In other words, all the robotics that you see people writing programs to control robots are really based on IoT. These kind of, very useful forms of variables. IoT. So you need to understand variable naming, as we talked about last week, so that is this a good variable name or not? So can someone tell me whether this is a good variable name or not? Switch on your microphone and tell me, is this a good variable name or not, and why? One VAR or one var, is that a good variable name or not, and why? So switch on your microphones. Switch on your microphones and answer the question. I want to hear you. Switch on your microphones and let me hear you, please. Is one var a good variable name or a bad one, and why?
So it's bad.
Why is it bad?
Innocent too.
Why is it a bad variable name? Okay, is because it has there's a number that prefixes it, so you don't start variable names with numbers. So you can't do 2x. This can be okay, or 2 rate. Like you can't do that. But if you actually, so this is wrong. This is wrong. This is all because the variable names don't start with numbers. Okay, but then you can do rate 2. That's a good variable name. Okay, the space, you know, you have to avoid the space. All right, you don't put spaces in variable names, put it in your head. Variable names don't have to be very long. Okay, so you can't just say my variable that stores many. And again, like you can't write some kind of sentence, long one. In fact, you want to avoid it. It can be very long, but it doesn't have to be more than 255 characters. Okay, and we need to know what a character is. The characters are characters. So tests. Okay, every single one of the characters that make a test. So when you write something like value, how many characters are in this word? Okay, so we have 1, 2, 3, 4, 5 characters. Okay, so you need to know these are basic things you need to know for variable names. All right. So the first one is V, the second one is A, the third one is L, the next one is U, and the next one is E. So we are recapping some of the things we talked about last year, especially the variable naming. So is this one, switch on your microphones again. Tell me if this is a good variable name. v.add. Is this a good variable name or not? v.add. Is it good or bad, and why?
Yes, it's good.
Yes, it's good.
Okay, why is it good? Why is it good? I think you are trying the national lotteries. You are just trying your luck, like those balloons that shouldn't burst. I don't think you know what you are talking about. This is a very bad one. Why
This
is it?
one, it doesn't start with numbers.
It doesn't start with numbers, but then it has the period sign. So because it has the period sign, it cannot be a good variable name. Okay, so this is a bad variable name. Okay, so this is bad. Okay. Meanwhile, if you had just done add, that would have been a good variable name. Okay, so this is a good one. So you see that in exam, these are the kind of questions I'll be asking you. Okay, so you can easily fail if you just don't know what you are doing. You just fail. And I'll just, this is how I am. I'm a very practical person, very honest person. I see something ahead of you, I'll tell you. Please, if you don't study and learn it, you will fail it. Simple as that. You can't even, there's no way out. Okay. All right. So variable names too, you don't use special keywords, special keywords. So in Visual Basic, there are keywords. You need to know a few keywords like DIM. So you can't name a variable DIM. You can't name a variable AS. Okay, you can't name a variable array. Okay, array. In case array is really a variable name, which I won't try to use an array as the word array because it's too dangerous. It may end up being a keyword. So if it's a keyword, you will know it's a keyword. You will know. All right, you can use integer. The word integer. Why? Because integer is a data type. You can use string because string is a data type, and so they are actually keywords. All right. In other words, in order to dimension, you can use the word for. Later we'll find out. You can use next as a variable type. Like why? Because these are keywords. Yeah. What are keywords? Keywords are special words that the computer understands. The compiler or the programming language is able to interpret in a particular way. All right. Meanwhile, variable names are just names we are given. Okay. If you like names and literals, if you see the word literal. So, for example, if you want to dimension a variable, you would have done something like dim v add, So assume your variable name is called VAdd. So dime VAdd as then you bring the data type there as string. So the keywords are dime, as, and a string. So we'll be doing this practical next week. God willing, next week our tutorial it comes on in this face-to-face. We are going to be writing a program, a very simple program, whatever it is, we'll understand what programming is about. And I'm going to have to squeeze a lot of things in there. I'm going to teach you some Excel. All of that is happening this week, face-to-face. So you have to be there. I'm traveling to, campus to come and do this lecture. Please, anyone that misses this, you will fail. Not because I say I'm going to fail you. You won't understand what this whole thing was about. Yes, but basically, what we've written on the board is actually a visual basic code, a line of code. Are you okay? So the algorithm, you can't even write this in terms of an algorithm, because in an algorithm, we start with the inputs. Are you okay? But then in the code, we dimension, that means we create space, we create memory locations where we can store values that can be accessed during the running of the program. What do I mean by that? I mean RAD, okay, could be assigned a value of say 100, but it should make sense. What does VAD mean to you as a programmer? Why are you storing VAD? Add, I don't know. Maybe it's a value to add. Are you with me? So the variable names have to make sense. So these are the things that we talked about. Well, one of the things we talked about last week, and in the previous lecture. So we need to also recap the data types. String. What's an example of a string? Are you okay? Remember that I said example will be Kofi. Kofi is a very popular Ghanaian name. Okay, don't be jealous if that's not a name that you can relate to, but obviously Kofi is very popular. Kwame is also another one. So anytime you are using, you want a computer to store something like a text, i.e. something that has been written like words, then you are dealing with string, okay? We also had Boolean. So the Boolean it stores true or false, okay? So we talked about this last week, and we even went ahead to look at operators. Are you okay? So true is a value. We can store true in a variable, say t. But before you can store a value, you need to dimension it. So if I clean up, I want to store a value true in t. I have to dimension t by doing dime, using the dime statement, which declares the variable t as Boolean. Okay. So having dimension at t, we can now set t equal to false or true. Okay. So if a value is true, then you can only operate, or true or false, we can only operate a logical or do a logical operation on it. So last, one of the things we talked about was the different types of operators. We can have arithmetic operators. We can have comparison operators. You can have logical operators, logical or bitwise operators. And I said that bitwise is where you look at, the on and off, where 0 is false, 1 is true, IAK bits. In computers, the bit is actually the smallest unit that you can actually store. But it would break down your storage, computer storage, you come to the bits. All right, so logical operators, okay, and then That's basically it. Arithmetic operators, comparison operators, logical operators. Then you are done. Then the decision is made. It makes sense. So that means that in every expression to be evaluated, we can evaluate the arithmetic part. We can do the comparison part. So example of comparison operators, then we are looking at something like 1 greater than 0. So the result of a comparison operator is a Boolean data type. Now, if you can hear me and you don't understand this, you better ask. The whole computer programming, not computer programming, actually information science and programming is a topic. The programming aspect of it, you need to understand. I'm repeating it again. You need to understand. If you don't understand, you can't go writing any essays. It won't work. You just be getting zeros. So if you have a question, feel free. This is the time to ask. And my cat, I think he wants to say hello to everybody. Yeah. So troublesome, isn't it? Okay, so 1 greater than 0 is actually what? True. All right. So we can store that in T. Remember, we've dimensioned T as a Boolean. All right. So this result is true. All right. And so I want to also to refresh the things we talked about in arithmetic operators. And the basic thing that everybody needs to understand in arithmetic operators is board mass. Bracket of division, multiplication, addition, and subtraction. Let's forget about this formula. But what's the relevance? What we're trying to say, we're trying to do what we call operator precedence. What is operator precedence? It says that if I have 2 plus 1 times, so in programming, don't write times, you write asterisk, times 0, then you need to evaluate from left to right, and then you need to do the additions first. You need to do everything in the bracket first, okay? Then you do multiplication, division. Are you okay? Then you do what? Addition and subtraction. Okay, so that's what mass. All right, so how do you evaluate? What's the answer to this? Bright, what's the answer to this? Elvis, David, any of you can answer it. What's the answer? 2 plus 1 times 0. What's the answer?
0.
So please, it's 0.
It's 0. Why is it 0? According to board mass, you do the bracket first. There's no brackets. Then you do the off. Then you do the division. There's no division. Then you do the multiplication. So you should do the multiplication first. So 2 plus 0. Then you get 2. So the answer is 2. So please stop the guesswork. Is that okay? You are being trained as engineers. So national lotteries that you are trying to be part of, it won't work. We won't let you go if you keep on doing that guesswork. It's mathematical, so you evaluate it. Engineers should always do a calculation and then make a decision. Okay. So 2 plus 1 times 0 is 2 plus 0. Scott. Okay. Now, so I can actually clean that and get a different answer if I introduce a bracket. So this is a GSS thing. I know you know it, just that you're so tired, most of you. We need to do the brackets first. So if you put a bracket in there, we'll do this and get 3 times 0. In that case, the answer is 0. So you see, we can just get different answers, okay? We can get different answers by simply using brackets, okay? I think the cat likes this thing and I have to put it away. I'm going to throw it out. The next time it keeps worrying me. Stay there. All right, so 2 plus 1, you do the brackets first. According to board mass, you do brackets first. Okay, then off division. So off is more like multiplication. Or let me just say, this is a mnemonic. Okay, a way to learn how to, do. So the F off doesn't really matter, but so that you can remember to always do the brackets first, do the division, multiplication, addition, and subtraction. All right. So, but of course, you know that addition is commutative. Okay, commutative. That means you can do 2 plus 1, 1 plus 2, and you're getting the same answers. Okay, so guys, this is algebra in disguise. Programming is algebra in disguise. Because we do this, we can do a complex expression of 2 plus 1 times 0. Then we now introduce another bracket at this end. Then we do greater than -1. Okay, then we can actually do and. Okay, so now we're making it more sophisticated. All right, so we now say and false. So you can be asked to evaluate this expression. All right, so what's the answer to this? The answer is everything in the bracket gives me 0, 0 greater than -1, and false. All right, so next week I'll probably give you a handout if you're interested, but of course you have to buy it at a certain price. Honestly, the system is really hard. 0 greater than -1 is true, and false. What does it mean? The final evaluation will now give us true and false, which is false. Okay, so we've evaluated an expression made up of arithmetic operators, comparison operators, and then logical operators. And then we have a final false. Now, so I'm sure someone is asking, so what? Are you okay? So everything that we evaluated here is representing the diamond symbol in our flow diagram. So the logic of the program is such that we need to evaluate an expression like that. And then depending on whether we get true or false, so yes, no. So no, we go down. Okay, so that is the whole essence of evaluating expressions in programming. We evaluate them so that a decision can be made. Are you okay? We evaluate them so that we can execute a particular code. Sometimes if the situation is true, we branch off so that we can actually continue computing or doing other logical stuff. So this is a branching of IOK. So that's what logic is about, that if a situation is true, go in a certain direction. But the situation has to be evaluated first. What I'm calling a situation is what we call an expression in programming, IOK. Okay, so algebra, this is like algebra, but at the same time, we brought in other stuff. Now remember that there is an interesting operator. There are 2 operators that all of you need to take care of that you are not probably used to. You are not used to this particular symbol, which is times. So 2 times 1, we don't write this, we write 2 star 1. I repeat it again. Also 2 raised to the power 2 will be written as 2, this symbol 2. So this can be found on the keyboard on top of number 6. Okay, so when you look at the number 6 on the keyboard, you find the symbol. Okay, so I'm going to actually get that symbol for you, so you can see it on the board. Okay, so I'm trying to expand it, but I think this is all I get. Yeah, so this symbol is actually exponential, but you need to actually evaluate the exponential first before you evaluate all the other expressions. So your board mass becomes your Boyd mass. In other words, you introduce an E into the whole board mass mnemonic, Boyd mass. So do your brackets. Before you do the division, you should be doing your exponentials. Are you okay? So it changes it a little bit. Are you okay? It changes a little bit. All right, great. So when you have, let's look at some, let's go back to our presentation. That's recapping the expressions, okay? We will talk about, we talked about scalar and an array variables, okay? So when we look at scalar and array variables, this cut, I'll beat this cartoon. Then you need to know that to dimension a scalar variable, you need to just do dim. So my array, so you have an array one that you want to store 4 elements. So what do you write here? 3. So this will now store a mixed data type of arrays of values. So we're not specifying that we want to store integers. But for beginner, let's start by specifying the values. So let's start with integers. All right. Integers. Let's try and smile. It's been a long day, but I think I have to smile. Integer. Okay, as integer. No S. All right. So what does this mean? It means I can actually store 4 things in there. Are you okay? Now, in reality, that creates something looking like a vector. So when Mr. Ankani was teaching a vector, when the Zoom session ends, please let's rejoin with the same link. He'll teach you something like this, isn't it? I'm sure you've done something like this. So the implementation of vector in programming is through an array. So how do you store this in Visual Basic? Okay, we've already dimensioned a variable to contain 4 things, and we have a vector containing 4 objects. Are you okay? Great. So my ARR1, array 1, then you provide an index. So the first index is always 0 because Visual Basic is 0 indexed. They want to store 20. Okay, then we keep going. The next one is for my ARR2. No, it's the same. So don't go to 2. It's the same variable, but we are just filling it with different values. So the array variable contains, it's like pregnant woman with twins or multiple kids. I don't know if I'm actually wishing for twins, but the same variable, but then you specify a different index. So in this case, if you go in that order, 0, 1, 2, 3, 0, 1, so 1, we store 4. My ARR, the same name, but different index to store 3. Then we're going to my ARR 2, 3 equal to 4. Then we have actually created the array we see as Vin over there. Are you okay? In other words, we could have, in order not to get confused, you could have even removed the my AR1 and replaced it with Vin. Okay, in that case, everything here turns to Vin, and then everything here will go, and then we put Vins there. Okay, and then we can actually dimension Vin, okay, as an array with 4 elements. Okay, so dim Vin, open bracket, 3 as integers. Okay, so now having done this, what can we do with it? The next thing we can do, in fact, I think I'll change the name. my ARR is going to waste my time. I have to write it every time I want to refer to it. So I'm just going to clean it up and put vein there. Okay. So that I'm consistent. Is that okay? So vein. Okay. And then I'm going to change my dimension. So I'm changing this. I'm still writing the program. So I'm free to do this change. I'm not bound to do this. Okay, let me clean everything up so that they are all together. So dim vein 3 as integer. And then the next question is that, so what? What do you want to do with this? Okay. What do we want to do with this? We want to actually add vein or multiply vein by a constant. Say times 2. Okay. Equal to y. So obviously we are going to get the same dimension. Okay. But we realize that the y now becomes a vector of the same dimension, a 4x1 vector. So we need to now dimension y as well. So it's, if you make a mistake, you can always go back. We need to dimension a variable called y. We can do it in the code, but it's good to group the dimension. This is what we'll be doing next week in practice, but don't wait. Don't wait till next week, then you're not trying to understand it. Understand it somehow to some point. The next week when we do the practical, you will not be totally lost. And all of you should install the Visual Basic .NET Express. Go download it. It's free. Download it. If you don't have money to download it, call me. I'll give you some money to do that. Okay, so dim y. So now we've dimensioned a new variable, array variable, not scalar variable. So it contains 4 elements. Okay, so the size is 3, but it's actually containing 4 elements with dimension as 3. Okay, so now we need to now do this multiplication. How do we do it? Okay, so programming is interesting, isn't it? All right, now the manual way of doing it is just saying y. So remember, in programming is not maths. So intentionally, I will not write here. In programming, everything we write goes on one line. That because I'm teaching you, I'm kind of mixing it up, all right, somehow. What it means is that I can't put this vein, what I do here, it cannot go into the programming language. We can't type that. Are you with me? I was only using it to explain to you. I'll put it back. So remember that it's not part of our code. But what you need to do is to then go to the next line and then start writing y 0 to be equal to 2 star vein 0. And then we will have the first element in the y, the vector y. Okay, then we repeat it. This is very basic. Okay, it's basic. There's another way of doing it. And so remember that, guys, when you write a program, it shouldn't look like your friend's program. And that reminds me that I give you an assignment. I'm about to inspect it. I hope you have it ready. You didn't send them to me, did you? When I give you assignments, you have to do it. I told you that you opted for this option. You were literally begging, we want to do it. Now you're getting the opportunity. Don't let yourselves down, guys. All right, so now here, we are simply multiplying the first element in the V array and assigning it to the Y first element. Okay, putting it, not assigning it, okay, assigning it to the first element in the array Y. And then we're doing that for the second element, which is referenced by 1 as the index. 3. So these are the indexes, the ones that I put there. These are the indexes, like an index number. Are you okay? They reference the position of the objects. Are you okay? So objects have been arranged in the stack like that. Talking about stacks. Anyway, I don't want to go there. It's a website called Stack Overflow. If you have programming problems, you can always go there and get a solution for it. Got complex problems, but even things like this, you can find them there. Okay, so if you have a question as you go, ask. Programming is, like mathematical. Don't assume that you get to know it. You will never. If you have a problem, let me help you. Okay, I'm offering myself to give you that help. Okay, so here we are. We have y. In theory, this is what we have. We have 2 times 20, so 24, 3, 4, 40, 6. So this is the new array we have. And this can be displayed on the screen for you to see that this is your new array. And this has a lot of application areas, but of course you will not understand it now. As a beginner, there's a lot that you wouldn't see. But arrays are used, are you okay, in a lot of applications. I'm so starved, I can't wait. I want to just have a bite of this biscuit. Allow me. The time is up. So the time is up. So please rejoin. Okay. Rejoin and let's continue with this array.